Welcome to this explainer. We all know humanity is heading back to the lunar surface. It's a monumental undertaking that's completely captivated the globe. But I want to explore a really fascinating tension here. Because while sending humans back to our nearest neighbor is undeniably thrilling, is this billion-dollar human adventure actually going to answer the questions that have been keeping scientists up at night for decades?
Let's dive right in. Look, the Artemis program is incredible, but it's funded primarily for political and economic reasons, furthering human spaceflight and setting up a permanent moon base. It is not fundamentally about pure scientific discovery. So if you're a scientist hunting for answers about how the moon formed, what's hiding inside its core, or the unexplained phenomena happening on its surface, the current Artemis flight plan actually presents a pretty huge problem. It really comes down to the base camp versus the global picture. Artemis is completely zeroed in on a specific region, the South Pole, to find resources that can sustain astronauts. But true lunar science? That's a whole different ballgame. To genuinely understand our moon's history, and by extension Earth's history, we literally need to map and sample the entire globe, not just one localized spot. So in this explainer, we're unpacking 4 key things. First, Artemis versus lunar science. Second, surface secrets. Third, deep inside the moon. And finally, the cost of discovery. Section 1. Artemis versus lunar science. The base versus the data. Let's start with the surface. Let's talk about water. Artemis wants the water that was mapped by the Sophia Observatory back in 2023 for life support, which makes total economic sense for a base camp so they don't have to ship it from Earth. But to actually figure out where that water came from, that requires zooming way in. We're talking about comparing the ratio of pure hydrogen to heavy hydrogen, or deuterium. It's like a highly specific chemical fingerprint that tells us if the water formed locally on the surface or rode in on crashing comets. And to read that fingerprint accurately, we need samples from globally distributed areas brought back to high-tech labs right here on Earth. Now you might be thinking, what about the 2027 Viper rover? Well, Viper is going to drill about 1 meter deep and roam just a single kilometer around the South Pole. It'll test that hydrogen ratio right there on the lunar surface, which is cool, but the precision is nowhere near what we'd get back on Earth. It will give us tentative clues, sure, but it just can't replace the global, robotic sample return missions that scientists are really holding out for. Moving right along to Section 2, Surface Secrets, Flashes and Fields. This brings us to a mystery that has literally been baffling observers for centuries: Transient Lunar Phenomena, or TLPs. We're talking about completely unpredictable, brief, bright flashes or sudden color changes on the moon's surface. What are they? Is it lunar dust acting like a giant glitter bomb? Meteorite impacts? Just weird telescope artifacts? It's incredibly frustrating because our orbiters usually have super narrow fields of view to take detailed pictures, so they constantly miss these sudden, broad flashes. An Artemis astronaut would have to get ridiculously lucky to just happen to be looking out the window and spot a TLP. To actually solve this, we need continuous global robotic monitoring with rapid follow-up capabilities. The European Space Agency is launching the Lumio mission in 2027 to watch the far side for impacts. But it doesn't even have a secondary instrument to rapidly zoom in and check if a flash was an impact, a dust cloud, or a true TLP. We're still going to be left guessing. And that brings us to mystery number 3, the moon's vanished magnetic field. Today, the moon has no protective magnetic bubble at all. But rocks from the Apollo era, they contain tiny bits of metal that act like frozen compasses. That proves the moon once had a churning, hot liquid core acting as a dynamo. So why did it just shut down? Artemis is bringing back new rocks, but again, only from the South Pole. The 2026 Lunar Vertex mission will investigate this too, but it's highly localized at Rainer Gamma. To truly crack this, we need rocks evenly distributed from all over the moon. Okay, Section 3, Deep Inside the Moon. Core and gravity. Let's dig beneath the crust for mystery number 4. Is the moon's interior solid rock, or is there a liquid layer hiding near the core? You'd think a dead magnetic field means a totally solid, frozen inside, right? Actually, scratch that. The data is way more complicated. Back in the 60s and 70s, Apollo seismometers showed a mostly solid mantle, but those were shut down in 1977. Then, in 2011, the GRAL mission mapped the moon's gravity and actually found evidence hinting at a liquid layer near the core mantle boundary. We desperately need a new network of moonquake detectors to figure this out. Now, Artemis is deploying a South Pole seismic station, but let's be real, its main job is just to make sure a permanent base won't get rattled to pieces by asteroid impacts. And the recent instrument on the 2025 Blue Ghost mission? It scanned down to 1,000 kilometers. That sounds deep, but it's just shy of the 1,300-kilometer depth where we think this mysterious core boundary actually sits. So close, yet so far. It totally falls short of the deep global network we require.
Which leads us to mystery number 5. Get this, there is an unexplained gravity anomaly hidden beneath a South Pole crater, and it is massive. We're talking 5 times the mass of Hawaii's Big Island, literally pulling the crater floor down by almost a full kilometer. It's one of the most fascinating discoveries made by the Grail mission.
This anomaly sits under the South Pole Aitken Basin, which is 2,500 kilometers wide and 8 kilometers deep. What is this incredibly dense weight? Is it the surviving, intact iron core of an asteroid that crashed 4 billion years ago? Or is it dense lunar mantle stuff that got dredged up and smeared around? Artemis is landing right on top of this, so astronauts might grab some useful surface rocks. But to actually know if this thing is a solid lump or scattered debris, we absolutely have to shoot seismic waves through it from all sides of the moon.
And that points us to a recurring, kind of harsh reality. Solving lunar mysteries requires long-term, globally distributed robotic sensors, not just a single human landing site. Something like the proposed Lunar Geophysical Network, or LGN, would be perfect. It would drop 4 evenly spread seismometers for 6 full years to basically take a giant ultrasound of the moon's deep interior. The problem? Right now, it has 0 confirmed funding to fly in the 2030s.
Which brings us to our final section, the cost of discovery. Humans versus robots.
Let's talk about how we allocate our resources, because the financial realities here are honestly breathtaking. I'm just reporting these numbers objectively, but look at this. Funding the 5 targeted robotic missions required to actually solve these mysteries would cost around $2 billion. To put that into perspective, the James Webb Space Telescope cost about $10 billion, and the Artemis program by the end of 2025, that's an estimated $93 billion. Obviously, that money doesn't just vanish into the vacuum of space. It pays for jobs and technology right here on Earth. But comparing $2 billion for dedicated science against almost $100 billion for Artemis gives us a massive reality check on where our exploration dollars are heavily flowing.
So, as you consider those numbers, I leave you with this final thought. Humans undeniably bring absolute magic and inspiration to spaceflight. But does that unparalleled inspiration justify the massive cost difference? Or should we be prioritizing the targeted robotic missions that will actually decode the true history of our nearest neighbor? It's a huge question. Thanks so much for joining me on this explainer, and remember to keep looking up.